The first thing that you need to do for this function, you want to go ahead and rewrite. Anytime you have that negative in front, you're going to pull that guy out, and this becomes x minus 2. So what's going to happen is you always want to reflect first, so this negative is going to give us a reflection over the y-axis, and that just means we're going to have the opposite. All the x's are going to be opposite x values, all right, which that's how we get our reflection over y. And then, even though it looks like we were going to go left 2 because it's a plus 2, when we factor that negative out, it's obvious to see that this is really a translation right 2. So that means x plus 2. Okay? Our parent function here is going to be 3 to the x. So then, notice how we're doing two things, both to x's. We need to do that step by step. So unlike the last problem where I changed x and changed y and I only had one set of extra points, we're going to do the x first, then do the x again. So we need to reflect first. So all the x's are going to be opposite. So let's get our original points. We have 0, 1, 1 base, negative 1 reciprocal. Opposite x is going to give us 0, 1, negative 1, 3, and positive 1, 1/3. Then we need to shift right 2, so we're just going to add 2 to all these guys. 0, 3, negative 1, gosh, Mrs. Weber, 2, 1, 1, 3, and 3, 1/3. There we go. Okay, so now we have our points, our 3 points. Our asymptote, which I always forget to write that on there, asymptote does not change because there's no vertical translations being done for this problem. So here's your points. I'm going to show you now how to kind of think through this in your head. So you always have the option to generate the points, but if I were doing this, I would first still start by rewriting. And then we know that there's a reflection over y, which means opposite x, and we know that we are going right 2. Okay, so I would start with the asymptote. I recognize that I don't have a translation. I start with that, all right? I'm going to go right 2. All right, this is my new 0, 0 right here. And what's going to happen is normally I would go right 1 up the base, but I have a reflection, so I'm always moving the opposite direction. So I'm going to go left 1 up the base. And then from 0, 0, I go up 1, and then I'm going to go, instead of left 1 up the reciprocal, I need to now go right 1 and up the reciprocal. And so these are my points. So I know this is 1, 3, 2, 1, and 3, and I knew this was a reciprocal, so I knew that was 1/3. Okay, the domain here is all real numbers. What's the range? 0 to infinity. What's the x-intercept? None. How is this problem different from all the rest that we've done? We can't see the y-intercept. Does one exist? Yes. How do you know? Right? There's no asymptote saying that this arrow is stopping, so it's going to keep going, okay? And it has to cross the y-axis at some point. How do you find, not specific to this, but to every single function for the whole year when we've been doing this, how do you find the x-intercept, or the y-intercept? You let x equal 0, and you solve for y every single time, okay? So our function is y equals 3 to the negative x, so I'm going to put negative 0, because I'm going to let x equal 0, and then plus 2. And what is 0 plus 2? 2. And what is 3 squared? 9. And now we have our y-intercept. And what about the asymptote here? Y equals 0. Okay. How many things are being done to f here? 2. Okay. What is the first thing? What is this doing? What kind of stretch? So we have a vertical stretch by 2. And what about this guy here? And then up 1. So what's changing here? X, Y, both? Just the Y value. We're stretching, and then we're translating up, okay? So if I were to generate the points, what's my base function here, my parent function? 3 to the x. So my points are 0, 1, 1 base, -1 reciprocal. So I have my 3 points. And then we're going to do the vertical stretch first, which means I need to multiply my y by 2. So that's going to be 0, 2, 1, 6, and -1, 2/3. And then I need to add 1 for my shift up 1. So I have 0, 3, 1, 7, and -1. What's 2/3 plus 1? 2/3 plus 1. 3/3 plus 2/3. 5/3. Okay. I actually don't have a problem with you guys putting 1 and 2/3 as well. Okay. The reason why you say this 1 and 2/3, that's how you actually say it, is because it's actually 1 plus 2/3. It's the same thing. All right. This will come in handy if you're trying to do this in your head. So for this one, I'm going to go ahead and draw 7 tick marks since I know I'm actually going up that far. 1, 2, 3, 4, 5, 6, 7. And then, okay. So if I were to do this in my head, here's what it would look like. I see that I'm moving up 1, so I draw in my asymptote first. Okay, so that is what I would do first. And then the only other thing I have going on is this vertical stretch. So I'm going to draw my parent function, y equals 3 to the x, but everywhere that I would go up, I'm going to go up twice as far. So this is like my 0, 0 here. So from here, where I have the asymptote, I would go right 1, up twice the base. 1, 2, 3, 4, 5, 6. And that point is 1, 7. Okay? And then from 0, 0, I normally go up 1, but now I'm going to go up 2, 1, 2, and notice that's our 0, 3. And then I go left 1, up the reciprocal of the base. The reciprocal is 1/3, but now I need to go up 2/3. And then I can draw my sketch. All right. So this is going to be the hardest point if you're doing this in your head. And that's where I was saying if you want to just do 1 and 2/3, that's totally fine because you're showing me, yep, it went up and then I had to go up another 2/3. 1 and 2/3 is fine, or write 5/3. Like I have no personal preference. I will take both answers. Okay. The domain here is all real numbers. What's the range here, you guys? 1 to infinity. X-intercept. None. Y-intercept. 0, 3. Asymptote. Y equals 1.